everyone. I am Assistant Professor Urmi Shah from ICT Department of LG Institute of Engineering and Technology. In today's session, we are going to move ahead with the pulse modulation technique. Up till now, we have studied what is pulse amplitude modulation, what is pulse width modulation, what is pulse position modulation. And all these three things are categorized under the category analog pulse modulation. Today we will be learning in depth how we can have generation of pulse width modulation and pulse position modulation. So these are the topics which we will be looking forward in today's session. In the upcoming session we will also learn how the three are compared with each other, that is comparison of pulse amplitude modulation and pulse width modulation and pulse position modulation. So these things we will be comparing in the upcoming sessions. Basically, pulse modulation technique itself means that you are having your input in form of pulses which will be applied to the transmitter block. Now what this transmitter block does, it will further process it to the receiver section if it is to be processed at longer distances then we require modulation scheme. So that process we are learning is pulse modulation technique. Secondly, in this session we will be covering following topics, that is PWM and PPM. PWM is nothing but pulse width modulation and PPM is our pulse position modulation scheme. Basically, why we are referring pulse width modulation or pulse position modulation and pulse amplitude modulation, like what are the purposes of utilizing or understanding these three kinds of modulation scheme. See, basically it depends on the application which we are designing, whether our application wants variation in form of amplitude, whether our application wants variation in form of width, or it wants the variation in form of position. So these are the three kinds of modulation technique which are applied in industry or in market based on the application which we are designing. Whatever the application demands, that modulation scheme we need to refer. Secondly, these are the topics which we are going to refer in today's session. And the first thing is how we will have detection of PWM. PWM signal generation we have already learned in the previous session. How we will detect or how we will demodulate the PWM signal. So this block diagram is basically used for PWM detection. Firstly, we will have our input from Smith trigger circuitry. From Smith trigger circuitry, we will have our noisy PWM signal. Noisy PWM signal will be applied to Smith trigger circuitry. Now what will Smith trigger circuitry will do? It will further process into two sections, that is our ramp generator and synchronizer pulse generator. Synchronization pulse generator will synchronize the signal in such a way that whatever the noises or whatever the extra interference signals have been accommodated will be filtered out and it will be further processed to the header circuitry such that it will be in proper synchronized with the pulses. Ramp generator is nothing but an integrator circuit. Integrator circuit will raise the parameters of the signal and it will further process to the adder circuitry. Ramp generator generally generates signal in form of sawtooth as it is an integrator circuit. So further it will be processed to the adder circuitry. Adder circuitry will act the summing of ramp generation and synchronization pulse generator, and then it will process it to the level shifter. What will level shifter do? Level shifter will do the shifting of appropriate levels of the pulses, and then it will further process it to the rectifier circuit. Now, in your basic electronic course, you all have learned what is rectifier. Rectifier is a circuitry which is very firstly used in our communication system over here. What does rectifier do? Rectifier basically converts AC signal to DC signal. Its basic role is it converts AC to DC. AC is our alternating current and DC is our direct current. So that will be done using the rectifier circuitry, and then it will be processed to our final block, that is our low pass filter. Now what will low pass filter do? Low pass filter will have the lower frequency content and it will block the high frequency content. It will only process the low frequency content. So this way the whole message signal will be finally detected at the output of low pass filter. So these are the blocks which are required for PWM detection. This way it will be finally demodulated and the output will be received in form of original message signal. Now here the PWM detector is having some specific role. What does it actually do? So the received PWM signal is applied to the Smith trigger circuitry, that is our ST circuit, and ST circuit's role is to remove the noise. Whenever a signal travels from a transmitter end to receiver end, in between in the communication medium or in communication channel, there are lot of chances of noises getting added to the transmitted signal. So at receiver end, it is a must requirement to keep a such circuitry that can remove the noise which had been accidentally entered into our transmitted signal. So for that we have a Smith trigger circuitry over here. Further, the regenerated PWM signal will be applied to the ramp generator, and it will be also applied to synchronization pulse. Heights of ramp is directly proportional to the width of pulses. Pulse generator produces reference pulses and these are constant with respect to the amplitude and width, but they are delayed by a specific amount. The delayed reference pulses are further added to the output of ramp generator, and the output generated or output is further given to the level shifter, and the negative offset shift waveform is generated. Then it is clipped off by the rectifier section, which is followed by a low pass filter. Low pass filter will have finally the output original message signal which was transmitted from the transmitter side. So this way the PWM signal has been originally detected by the PWM detector. This is the waveform generation or the output waveform of demodulator section of PWM. Firstly, we will have the PWM signal, which is, you can say, having different widths of pulses. Then it will be applied to the ramp signal, and then it will be applied to the adder circuitry. Then after adder circuitry, we have the filtering process of the signal, and finally at the low pass filter, we will achieve our original message signal. So this way, the whole demodulation process of PWM signal is done. Next type of modulation is pulse position modulation. Now, PPM is an analog modulating scheme in which the amplitude and width of the pulses are kept constant and the position of each pulse is varied with reference to the position of a reference pulse, and it is varied in accordance to the instantaneous sampled value of message signal. The transmitter has to send the synchronizing pulse to keep the transmitter and receiver in synchronization. These sync pulses are used to maintain the position of pulses. The PWM is the signal which we saw in the previous slide. Over here, once the PPM is done, it will be in accordance with the PWM signal only. The output will remain 0 until it is triggered on the trailing edge of PWM. So yes, this is the thing which will happen in pulse position modulation, that whenever the output will be generated, it will be remain 0 until it is triggered at the trailing edge of PWM. And the output of the monostable multivibrator, it will switch to positive saturation value A, and it will remain high for some specific fixed period of time until it goes low or it goes 0. Hence, the position of the pulses is in proportion to the width of PWM pulses or PWM signal pulse. So this way the PPM modulation occurs. Now what are the disadvantages? What are the advantages of pulse position modulation? Basically, the advantages are, as the amplitude and width remains constant in pulse position modulation, the power handle is constant. See, in any circuitry right now, if you are designing any product in market, the basic requirement is speed, cost and power. If one of the parameter is satisfied in high amount, that means your design is quite optimized. These are the three parameters for optimization of products in market in today's time. That is power, cost and speed. So this is one of the very basic or very important advantage of pulse position modulation. The disadvantage of pulse position modulation is synchronization. The synchronization between transmitter and receiver end is a very important necessity which is not done over here. So that is one of the drawbacks. This is the signal generated. You can see over here, the first one is the pulse width modulation signal. In the pulse width modulation signal, you can see the different width sizes of pulses, and over here you can see the different positions of the pulses. Like the gap between the two pulses are not same. So this way the whole PWM signal generation and PPM signal generation occurs. Now the PDM is differentiated and it is then rectified and then it is shaped. PPM carries exactly the same information as long as the position of clock pulses is well defined by the received signal. PPM is superior in compared to the PDM, that is differential pulse modulation, for message transmission, and since the wide pulses of PDM are require more energy than the PPM when transmitted, so it is not frequently used. PPM is suited for communication in presence of noise, and very high peak narrow pulses can be transmitted and pulse position can be determined even when the noise level is high. However, transmitting very narrow pulses requires a larger bandwidth, and whenever the light is intended on the media for transmitting analog signal, PPM or pulse code modulation are the most suitable types of modulation because the maximum power output in the modulated light source, which is LED or laser, is achieved and the duty cycle observed is also very low. In PPM necessary to transmit a series of sync pulses at a much lower repetition rate than the sampling pulses to avoid interference with original signal, and the minimum or minimization of number of pulses which is transmitted in order to conserve the transmission power. So this way the whole process is compared. The transmission bandwidth of PWM and PPM we will be discussing in the further session. Thank you so much for watching this session and following other references for the session which we have discussed today. Thank you very much for watching this video.